Thank you for going through this training. My name is Ashish and I wanted to quickly introduce myself. Before I start further, I wanted to have a disclaimer here on the screen that I work for AWS, but the views which I am sharing are my own and they do not represent my employer. About me, I am passionate about technical training and empowering individuals and enterprises to learn technology in the simplest possible manner. I have been into industry for a long time and have been into various roles. I have worked as a authorized instructor for Microsoft, Cisco, VMware and Veeam. I hold various technical certifications from industry leading vendors. And so far I have trained 5,000 plus learners in various technology in a classroom learning. On personal front, I am a native of India. I worked in India and Dubai for a while and now I am based in London. Let's focus on the training now. You may be thinking there are so many AWS trainings available on Udemy. What makes this particular training unique? I'll give you not only one, but four reasons, and probably you would relate to all the things which I'm saying once you go through this particular training. First reason, I plan to keep this training in a classroom style. I don't want to just record a video and post it, but I want to keep it in a way that you will feel that you are sitting in a classroom and you are learning directly one to one from me. Second reason, you will learn technical concepts through a lot of simple analogies. Sometimes we get so lost in understanding technology that we do not relate technology to the real life or day-to-day scenarios. You would definitely enjoy making this connection by learning technology through simple analogies I would be using in this training. Third reason, in this training I will focus on why of the technology. Sometimes we are so focused in just knowing what and how. For example, what is a service, what is the configuration associated with this, what settings are available, etc. And we fail to understand the why behind the technology. Why somebody wants to use this technology, what business problem they are trying to solve, or what benefit this technology will bring to your business or your day-to-day work. So I would focus on that why component and not just what and how of the technology. Fourth reason, I would be combining multiple mediums to share knowledge. I would be using whiteboard, demos, and slides to effectively explain the concept and services. Some topics are well explained through demo directly. Some would require some understanding, so I may use slides. Sometimes I would be much better explaining things through a whiteboard, so I would be using multiple medium to explain you the concept. I hope you would enjoy this training and will learn new things. I would also like to connect with you through LinkedIn. If you have any suggestions or feedback, please do reach out. Also check the last module of this training to know about the other resources which I have created to help learners in learning most about AWS Cloud. So enjoy, learn and share. Thank you for your time. Let's talk about databases in cloud. Most of the application you are using would have some type of databases behind the scene. Databases is a good way to store data in a structured format so that if required, we could track back that data, we could query that data and get the result and maybe satisfy business or technical requirement of my application. So let's see how we have different type of database options in the cloud, how we implement these solutions in cloud. But before we discuss about implementation details, we need to understand some of the basic difference in the way databases store data, and that brings us to discussion of talking about SQL versus NoSQL databases, or I would prefer to call them relational versus non-relational databases, right? What we are discussing here is a pattern how the data is being stored inside a database. Like if you look here, this looks like a tabular format of storing data, whereas this side here, it looks like a hierarchical format of storing the data. The data may be same, but the way we store could be little differently implemented. Now, I personally don't prefer to call them SQL versus NoSQL because now our non-relational databases have evolved so much that even they can understand SQL. So you could run a SQL query on a traditional relational database, or you could also run SQL query through some type of engine or some type of middle layer in between, so that your non-relational database will also split or will also spit the output into a SQL format. So that's why I prefer to use relational versus non-relational rather than calling it SQL or NoSQL. Let's try to understand the pattern of data by using an example. Let's take a recipe card here. This recipe card is for making a banana bread. On one single page, I am getting details about the ingredients required. I am getting details about the steps to follow and more information like how much time it takes, is it easy recipe, how much it would be sufficient for. So this is one single page in a recipe book in which all the detail to make banana bread is there. I don't have to keep on going to different pages into the recipe book. One page is good enough. If I keep on following and if I all ingredients, I would have the banana bread baked up for me, right? I haven't tried this, I've just taken the picture, but in case you try this, let me know how this bread tastes and maybe I can give it a go. Now, let's focus on these ingredients. Now, you may be thinking why I'm talking about banana bread and all. I would relate these concepts into a minute and I will explain you that how this is representing a type of database. So in this case, if I have to get these ingredients required for banana bread, obviously I have to go for grocery shopping. If I go to grocery store, what you will find that they have stored these items in different racks, and I may have to go to different racks and then what I am looking for. So maybe for banana, I would get it from here. Maybe I need drinks like milk and all, I would get from here. Maybe I need some crisp, may I need some cheese. So what I'm doing, I'm filling up my shopping cart by items which are coming from different racks. Think of these racks as your tables in which your data is stored. And you run a SQL query, which is your shopping cart, and to satisfy the query, what would happen? Probably that your data may be pulled from multiple tables, combined together and then delivered back to you. That's what is a traditional SQL database is. Here, the data is being stored into different tables, and when you run query, that time there would be some way by which your SQL engine running behind the scene will pull up data from all these locations, massage it as per the way you want or as per the query you requested, and then deliver that data to you so that you could process it further. So idea here is my data is spread, and obviously there may be some relationship between these tables, like probably these two things needs to be kept cool, so they would be kept nearby so that this will be maybe whole cooling fridge, right? Just giving an example, it could be anything, but there is some relationship between these things which are being stored inside these tables. On the other hand, when I had my banana bread recipe, I did not had to go to different places. Just one page has all the information. This is a type of a non-relational database which is into play. In one document, I am getting all the information I need, whereas in case of a traditional relational database, my data would be spread across multiple tables, and then I would be running query which will bring data from different places and deliver me the result if I am looking for what I am looking for, right? So differentiation between them. SQL databases are optimized for storage. What I mean by that, I'll explain that in a minute. NoSQL are optimized for performance. I'll explain that too. Now, data storage in terms of SQL database is rows and columns. All my data is stored into rows and columns, and I would have tables, and through these tables my data would be stored. So let's say this is my music table, and then there is a artist information here, maybe album information here, and that's how I would create relationship between these databases, and that's why they are called relational databases. These are all representing different tables, and by combining a table and then running query against it, I would get the result. Whereas if I'm talking about NoSQL database, maybe NoSQL database stores my data in a document format like a recipe card. And then everything is available here. If I'm looking for, let's say, year for Jane Doe, first and last name, I would just need to go to one document and I would get this information. Whereas in this traditional way of doing things, maybe the name is stored in this table, maybe the year is stored here, and maybe the ID is stored here, and there would be some relationship between these tables. So hope you are getting the idea. Now, let me explain what we mean here by SQL databases are optimized for storage and NoSQL databases are optimized for performance. Let's talk about it. Why this is. Let me show you a picture here. If you're guessing, this looks like very old picture by the way people have dressed and the way it looks, the black and white kind of a stuff, lot of manual work happening, and it has something to do with technology. As I can say, this is IBM Data Processing Division. What you are witnessing here, it is a 5 MB hard drive being shipped from IBM. 5 MB. Imagine that. So 5 MB hard drive is being shipped from IBM, and this was called a portable hard drive. Yes, it is portable with 8 men and 1 van. It is portable. Now, what we are trying to explain here that how storage has evolved. See this picture now. What you are seeing here on your fingertip, there is a 1 terabyte memory card. So in early days of computing, storage was very costly. Very huge cost was there for storage. So whatever systems were designed, they were designed in a way that they would optimize storage. Instead of keeping data in duplicate fashion, they would ensure that data is kept uniquely, and then we build relationship on top of that data to get that information. And that's what I meant when I said my SQL databases were optimized for storage. They were trying to minimize the space consumed for storing data, whereas by the next time, like this happened around 1970s, somebody in IBM invented these relational database, and there is nothing wrong with that. We still use a lot of relational databases, but as technology evolved, let's say when Web 2.0 came mainstream, applications like Facebook and then Google and Amazon, where millions of users are using the application, the traditional approach of SQL based databases was not scalable enough. And that time, what used to happen previously, as your data load keeps on growing into your database, the query will become slower and slower. And if I'm talking about an application which will be used by millions of users, and if data keeps on growing every day, my SQL query or whatever query I am writing would keep on becoming slower and slower. We didn't want that, and that's why this new breed of databases were created. Those are referred as NoSQL database, which are designed for performance, optimized for performance. So whether one user is accessing the data or one user's record is there or millions of users record is there, they can still give you the performance which will be optimized for your workload. So that is what we mean by a NoSQL database. If you look here, I have mentioned different type of storage techniques. In a SQL database, data is stored in tables and rows and columns, but in NoSQL, there are different ways to store data. One I have displayed here is a document format. This is a document, not your Word document, but typically a JSON document. And here we have data being stored into a key value format, and we may have a hierarchy like this is a top level unit, and within that we have first and last name, and this is another independent unit which we are storing inside. So that is a document way of storing the data. Another way of storing the data could be a key value pair, very common. Right, so I want to store someone's name, so name it will be a key and the value will be whatever the name is. I want to store someone's age, and then age would be something here. So that is what we are referencing here as a key value pair. Now this is same data but put together into a different format. Then we also have another way of storing data, which is graph format. So graph format databases are good when you have lot of relationship data to be maintained. Like when we have social media application, A is friend with B, B knows this person and C knows that group, or C likes that product. So when we need recommendation engine, when we need to do fraud detection, when we need to do social media networking, that time this graph databases would be very helpful because they are storing the relations inside a database. Right. So question you may have, can I not deliver the same result from SQL? Yes, you can, but it is not optimized for it. The time and effort required to create this kind of a relationship structure and to create optimization will take more of time, and that's why these can be a very specific use cases which you want to fulfill by your key value pair graph or document, and one more which is referred as wide column. So these wide column databases are very good way to store your analytical data, when you have a lot of analytics to be done, that time maybe you could utilize this wide column databases too. We will focus on some of these aspects as we move forward. So I hope this thing is clear that what is the difference between a relational and non-relational database. It is the way they store data, right? Let's talk about a little bit more details on that. When it comes to schema, schema is the pattern how I am storing the data. So maybe we have created schema that we would have name here. Maybe we would have age of the person here, and maybe we would have, let's say, date of birth of that person. Just giving an example. So this schema somebody has thought initially, and that would be followed throughout the life cycle of the database. Schema design is an important aspect for SQL or relational databases because once you designed that and once you implemented it, it has become fixed, right? And let's say if you have a person's to be value to be stored, let's say name is XYZ, maybe you do not know their name, maybe you do not know their date of birth, so you can't keep them blank. Technically, what will happen that the system would fill itself with the null values here saying that, hey, this data is not there, so null value has to be added because it expects is to have all have the fixed schema, like you have a form to fulfill and in that first name and last name is required, that is a fixed schema. Now what if somebody has first name, middle name and last name? Now my upper section of the form is not designed for it. That is a fixed schema. Only I have first name and last name, but maybe sometime I may want to keep my schema dynamic. What if I come up with the situation that like for some people, they may have first name, they may have a middle name and they may have a last name. We want flexibility. So if you're looking for that flexibility that your schema can change, that time your NoSQL or non-relational databases are good. I am trying to depict it here. So some records which you see here or some items which we call them, we may have here things like this one has two attributes inside, this one has maybe 5 attributes, again 2 attributes, again 4 attributes. So that is completely okay with NoSQL databases. They expect schema to be dynamic and it can evolve over a period of time. There may still be some mandatory values, like let's say the first field is required and then second field, third field or fourth attribute or fifth attribute is not required. That can happen. That is what we mean by a dynamic schema, right? When it comes to query these databases, SQL databases support just a SQL statement. Probably you have at least seen some SQL somewhere in your life. So see this thing here, very simple one. So we want to return all of the song by artist Elvis. So we say select star representing everything from the table called music, where the value we are looking for, where the artist information is Elvis, and deliver me all the song by the artist Elvis. Now I could write the similar type of query for NoSQL databases too, but the format would be different. Like here, see this. What I'm looking for? I am looking for same thing, return all of the song by an artist Elvis. So here I am specifying my table name is music and I am creating a key condition expression which says artist should be for the value variable A, and variable A's value we have provided or attribute value we have provided is Elvis. So this is the way how I would query these NoSQL database. This is just one example. Some NoSQL databases would have a very specific way of querying the data, or some may support SQL also. Right. So focus here is on collection of document. This is a whole document returned to you, and then from there you would be able to filter whatever you require. So here the focus is on collection of the document, not on individual items within it. Right. Hopefully this thing is clear. When it comes to scaling, scaling is a method by which I am able to address or honor when lot of requests are coming to my database. So in SQL databases, if you need more performance, you would do vertical scaling. You would keep on throwing more CPU and power to your database and keep on increasing in size, and that is how you would satisfy a number of queries which you can handle. Right. But you would soon hit a limit that how much economically you can put it into a box, because technically whatever the size of database is, it is still running on one single server most of the time. Yes, clustering happens, but let's consider that vertical scaling says if my server is not able to provide me capacity, I would replace it with a bigger server. I would replace with a bigger server. You would soon hit a limit that how much economically can be packed together into one server in terms of CPU and memory. So that's why we may hit some limit once we go beyond a specific point. That's why this, because we are using here a vertical scaling, right? How tall you could build a building, right? So your Burj Khalifa, 150 plus floors. Can you make a building of 200 floors? Maybe. How many? Very less, kind of a thing. So there will be some limitation which you may achieve once you start doing vertical scaling. But in terms of NoSQL databases, we utilize horizontal way of scaling. If you see this dotted line, consider we have created a cluster. And we may start with one node. If we need more capacity, second node, third node. If I need more, I could keep on adding more nodes into my system, and I should be able to horizontally scale my data need. Should not be a problem. So hopefully this thing is clear. This is a horizontal scaling and vertical scaling, right? Or you could go ahead and say this one, what you are seeing is a mechanism called scale up. I'm upgrading or getting up from what I had initially. And this one is referred as scale out. I'm scaling out. An opposite of that will be scale in. An opposite of scale up will be scale down. When I do not need, maybe I could bring it to smaller size. Instance should not be a problem. So hopefully this difference is also clear to you. The next difference is the way the transactions are processed into your database. What is a transaction? I don't want to go into the technical definition, but let's see that. Let's say I have a bank account here into, let's say, Barclays Bank. And from Barclays Bank, I am transferring data, or sorry, transferring money to HSBC as a bank. Now, what would happen? I would have my account here. That is, let's say, A's account, and I want to transfer money into account of B. So this process of transferring data where I would initiate something, that request will be processed by Barclay. Barclay and HSBC will be probably member of a common banking system. From that banking system, things will be processed. The data would be sent to HSBC. HSBC will perform its internal verification whether the account is active or not, whether it is a valid transaction or it is a fraudulent transaction, or maybe some other security check. And then the data would be, or the money would be transferred to the B. And then B could withdraw that money, right? So what you are seeing here is a transaction. Now, in case there was some issue for HSBC and they could not receive it. So let's say if I send $100, either this person B will get $100 or it won't get $100. So it will be a binary way. Either it will be successful or it would be unsuccessful. It won't happen that out of 100 only $30 could be passed out and 70 returned to my account back. No, either it would go fully or it would be reverted back fully. That is what we mean by a transaction. So in SQL databases, we expect that transactions would be happening, and they use a very specific word to explain transaction that is called ACID support. So that is called atomicity, consistency, isolation, and durability. So that is a beauty of SQL database, that every transactions are happening either all or nothing. Only valid data is saved. If there is inconsistency, it won't be tolerated, it won't be saved. Transactions do not affect each other. So from my account, if I initiated one transaction of transferring $100 and another transaction was to receive $10, they are both treated separately, and you would have durability, which means return data won't be lost. This is what we refer as a ACID compliance. Now, this may not be very prominent now, because obviously SQL databases support it, but this support is also coming to NoSQL. Some NoSQL databases support this type of transaction too. So I won't say that it will always be true, because if I'm talking about Amazon based services like DynamoDB, in DynamoDB transaction support is there. You could follow transaction, but in technical term, this type of databases are referred as base compatible. like acid and base in chemistry, kind of opposite. Same thing here. This is basically available. System does guarantee availability, which means your data would be available, right? But it can be into soft state. It may change over time. Don't worry if you don't understand the soft state. We would talk about it, and your data may be eventually consistent. Maybe in a while everyone would have the same data available, but there may be a transitioning phase where some node may have the latest data and some node may still have old data. So that is the difference between SQL and NoSQL, or relational and non-relational database. We can go into more technical details of differentiation, but I think it is a good enough point to get started now. So hopefully this thing is clear. And in the next topic, we will discuss about the way AWS implement databases into cloud. So I hope you enjoyed, and I'll talk to you into the next section. Thank you. So hopefully by now you have a better understanding of relational and non-relational databases. Let's focus on relational database now, and we will talk about one specific service which is called Amazon RDS, or Amazon Relational Database Service. To understand this particular service, we have to understand what is a managed service in databases and what are the options we have to run these databases. That would give you a better understanding on when to use which type of service. Right. So if you want to run and maintain databases, there are multiple options for you. Probably you have already done this type of work in on-prem. So when you are working with a on-premises database or you're hosting an on-prem database, first thing you have to worry about is racking and stacking your servers. You would worry about cooling and ventilation. Your physical server will be then ready. On that physical server, you would have operating system which is supported. Operating system would require patching. Then once it is ready, then only you would go ahead and install a database. Database itself requires patches. Sometimes a vendor would vendor would release patches and you would have to install it to make it up to date and secure. Once this is done, you would plan for backup. Probably you will use some third-party tool or the vendor provided tool for backups. Then you would configure high availability, ensuring that my database can work even if there is some failure. There is a standby available who could take over when the primary fails. And when when your user traffic increases or your database usage increases, you have to worry about scaling also. So all of these things are managed by you if you are running these databases onto a on-prem world, right? So if you move to cloud, one option you could follow is, hey, I don't want to worry about operating system, physical server, cooling and it. AWS already have Amazon EC2 instances, so why don't I run my database on Amazon EC2 instance? So in this case, AWS would take care of racking, stacking, cooling, ventilation, physical server, and give me an operating system which is there. Once I have this thing sorted, I would then log into that operating system, probably apply the latest patches which I need, install the database software on that, again patch databases, configure backup, configure high availability, and configure scaling on that. So that is one way where I am relying on AWS to provide me the infrastructure, and once this is ready, on top of it we manage the database. But still there is a lot of tasks which you have to manage. Why can't we find a better solution? Answer is better solution exists, and that better solution is Amazon RDS. So once you go with Amazon RDS, most of the activities would be taken care by AWS. Right? So AWS, based on the selection you do, obviously it will take care of things to OS patching, but beyond that, it would install the database on the server of your choice, and other activities will just become a checkbox activity. Do you want patches to be applied automatically? Yes, select a checkbox, done. AWS would take care of that. You want a backup to be performed at a very specific time? Yes, you could do that. You want an architecture of high availability to be implemented for your databases? Go ahead, select a checkbox and everything behind the scene will be taken care for you. And you can also do something we refer here is called push button scaling. It is still at the end is a EC2 instance which is fine-tuned to run databases. So if you feel that you started your instance on a T2.micro, probably you won't be running any production workload. But once you tested this on T2 micro, you may go for a DB5 or some other extra large instances if the need be. So that push button scaling would also be built into the service. So here you could clearly see that your responsibilities are much lesser, or basically you just have to select the setting and then you can focus more on your application code, writing your efficient query, verifying the performance, adding the security. That would all be taken care by you, and AWS would be managing a lot of stuff for you. So what you are seeing here is a unmanaged and managed service. The approach which we see on the left side, these are your unmanaged services where you manage a significant portion of the service. On-prem, obviously you everything manage, but when a database is running on EC2, then you still manage a lot of stuff. What you see here is a managed service. And through this managed service, you are able to focus on what matters to your business rather than doing undifferentiated heavy lifting. So we will focus on Amazon RDS now. Let me talk a little bit of theory of RDS and then I'll go into console and show you a demo on how to create this RDS database. So when you want to create an Amazon RDS database, you have to first select a database engine, right? So you decided, hey, I want to take a car. You decide what model of the car you may look for. Similarly, or which vendor car you would be going for, right? Similarly, when you are deploying a database, Amazon RDS gives you option to select from common open source databases like MySQL, Postgres, and MariaDB. I have put them into a different category because these are all open source databases. If you are looking for commercial database solutions, which are very popularly used by enterprises, Microsoft SQL Server or Oracle, that is also one of the engine available. And there is one more Amazon's own engine available, which is called Amazon Aurora. So you can select any of these engines depending on your use case, depending on what type of data you want to keep, what is your business and technical requirement. You would select any of these engines to get started. And once you have selected this, you would just go through a wizard-driven process, specify your requirement, and AWS would spin up the required component and required services for you, give you a connection string for your database, and you will be getting ready on that. So through this process, what you would be getting? You would be getting a database instance. Now, database instance and databases are two different things. Think of database instance is the server which is housing the database software. So you said, I want a database instance. In that database instance, what you would have the required CPU, memory, and disk configuration. So that would be running on instance behind the scene. There would be some compute server running behind the scene of this database instance. And on this database instance, you would have that vendor specific software running. Let me call it just a database engine running on top of it. So that is a database instance which has a compute backing it up, and on top of it a database engine is running. Once you have this database engine, it will be providing you something called a connection point. Connection point is the address. Think like a IP address or a DNS name for the database. And through this connection point, you would use any tool of your choice. Could be a tool which is provided by the vendor, like Microsoft SQL Server gives you a SQL Management Studio. Like for MySQL, you have something called MySQL Workbench, so you could use that. And now once you have this connectivity, probably you will open any of the database connection software here, and through that you would connect to this database, and afterward you would start building your databases on top of it, and those databases would contain your data. So one database instance can have multiple databases hosted on it, shouldn't be a problem at all, right? And you would be then using applications running in your EC2 instances or on-prem or maybe in other places, and they would be then allowed to communicate to these databases depending on the permission you configure, depending on the connectivity you configure. So we'll go to RDS console and would deploy a MySQL database, and on that MySQL database, once it is ready, we would go ahead and add more component. Those components are referred as high availability component or a read replica. So once my MySQL database would be ready, I would also show you how we can make it highly available and add read replica. So that feature is there into Amazon RDS, right? So we'll talk about that. So let me go to console and get started by showing you a demo of deploying a small MySQL RDS database. Let's see this thing into console now. So I'm going to AWS Management Console, and the service I'm interested is RDS. I would check services and I would find lots of options for databases. We will talk about some of them in this course of training. Let's focus on manage relational database services, which is RDS. So my requirement is very simple. I want to just see how to set up a database and then add some additional things in that, like I want to have a multi-AZ setup or a read replica setup. So I'll walk you through the process of it. What you see here that I am into a region, and here is my DB instance 0/40. So this 40 is a soft limit. AWS just want to ensure that the account doesn't get abused and that we have sufficient capacity behind the scene, or AWS has sufficient capacity behind the scene to allow users to create databases. So this soft limit exists on account. If you want to go beyond 40 databases, you have to raise a support ticket. It is automated process in most cases. You would go ahead and say, I want my limit to be increased. You put a number. AWS will check based on your previous history, how much you use, and they would be able to increase your capacity. So this is a soft limit. Don't worry, if you are hitting that limit, you could raise a ticket and then get it sorted. Now I would go ahead with a DB instance. So I'm on dashboard, but if you see here, there are a lot of options available. There are databases, there is a query editor, performance of it, snapshot. We can export databases snapshot to S3. Backups can be configured. We will talk about some of them. Let's focus on creating a database as of now. So I would select create a database. Now, when I'm selecting to create a database, the first thing I have to select is what is my database engine, what I am looking for, what is my requirement in terms of what type of database is it. Is it a MySQL, is it a Postgres or MariaDB or something else? And once I have selected that, I would move forward. So I have to select a creation method, create standard or easy. Easy would ask less question, but I'm looking for answering more question on by myself. So I would standard create, and here are engine types. Aurora is available in two flavors. We will talk about that. I'm skipping it as of now. MySQL I could deploy, MariaDB, Postgres, Oracle, and Microsoft SQL Server. And when you select a specific engine, you would be able to see options associated with it. Like this one is a MySQL Community Edition, and you could select which specific engine of MySQL you want to use. So it depends on what your use cases is. Let me go with default 8.0.28 is what I am selecting here. Right. So here are some details. So this tidbit information is useful. Support database size up to 64 TB MySQL. Support general purpose, memory optimized and burstable performance instances. Support automated backup and point-in-time recovery, and it support up to 15 read replica per instance within a single region or 5 read replica across cross region. We will talk about that. So this is my MySQL which I am starting. I could filter based on some of the parameters. Now, template is a way to tell what is your use case for this database. Are you going to use it for production? If you do that, it will deploy a multi-AZ or multi-availability zone cluster for you. You may say this is just for dev and test. So in that case, maybe I could still go with multi-AZ or I may go for single AZ. But if I am selecting a free tier option, then I would be only given choice to select the free tier instances on that. So I am saying here, okay, I want to use it for free tier. A single DB instance not supported for multi-AZ cluster snapshot. So that is completely fine. I'm okay with free tier. And if you're doing these things on your own account, ensure that you use free tier resources. Otherwise, you would end up paying money for that. So this database instance, or you could think the server on which the database engine would run, would need to be identified, and I could give it a name. Like database one seems a okay name for me, so I'll keep going with that. This is a traditional database engine which has a username and password. So that username is admin, and if you want to set up some password, you could do that too, right? So here is my auto generate a password. Here is an option which you can use to use secrets manager as a service for managing the passwords. But I would go ahead and say, okay, auto generate a password for me. I don't want to manually select password at all. So RTS can generate password, or you can specify your own. I have selected auto generate password for me. Next thing here, I am specifying instance configuration. This is the backend system who would run this database engine, and I could have selected different options here. My options are limited here because I just selected free tier. Otherwise, I could have deployed a DB instance on different type of environment. These are all my T type of instances available. But if I have selected a different setting here at the top, I would have different options to choose from. Now you see DBM5.extra large, DBM5D.extra large, and you could select a very big machine too, like 96 CPU and 384 GB of RAM. It may be costing you too much money, so be aware about what you select. I would go ahead here and select the free tier instances. That is good enough. I am just showing a demo. I do not need to run a production snapshot or production workload on that. So it will be giving me a database server with 2 CPU, 1 GB of RAM, and 2085 Mbps of network throughput. This database would require a block storage, so that is being defined here. So general purpose GP2, baseline performance will be given, and 200 GB. Now I would keep it smaller because I don't want to pay unnecessary money. I don't have any use cases for running it on a 200 GB. So I will still keep GP2, but I would just say, hey, allocate 20 GB. I don't need more than that. Here is the option which says enable storage auto scaling. So probably if you know about database admin's world, then you have to do a lot of adding of storage as your database grows, which steals a lot of time for database admins. Now this just has become a checkbox. So you say we would keep on adding storage as your database fills up or the space fills up. We will keep on adding storage, but we won't go beyond the maximum threshold you have specified. So it would keep on adding chunk of storage, and then you would be reaching up to 1000 GB if you want. I do not have a use case for that, so I would remove it. This is important, connectivity. So database would be hosted inside a VPC. Let me draw that, and it would be much easier for you to relate to what I am talking about here. Right. So give me a minute. This is your region. In that region, you would have a VPC, right? So this is, let's say, is the VPC I'm operating in, and that VPC would have subnet across multiple availability zones. So let's consider this is your AZA and this is your AZB. As a best practice, what we will probably be doing that we would be hosting our databases into the private subnet rather than public subnet. So this can be my private subnet, and here I would be hosting a database. How a database selects a subnet to get hosted? For that, we create an entity, a logical setting which is called subnet group. So a subnet group is the allowed subnet on which my database can be hosted, and you can include multiple subnet on it if the need be. So let me show you subnet group, and then we would keep on adding those components in a minute. Right. So going back, so we don't want to connect to EC2 instance as of now, so that's fine. Here is my VPC. I have a default VPC which I am leveraging. So let me go ahead. This is not default, but yeah, means I have not created it, was existing in my account. So I would just use that. And here is my database subnet group. So in this database subnet group, there would be some subnet associated. Here is my link. I'll open it into a different tab, and you would be able to see that on which subnet my database would be getting deployed on. So better would be that you create a subnet group in which you enable only the private subnets, and then only your databases would reside on to a private thing. So see this, there are two subnet number this and subnet number this, which are part of my subnet group. If I want to modify, I could, shouldn't be a problem at all. So I could go ahead and add more detail into my subnet group if the need be. Okay. Now, what I'm going to do, I would keep on following this wizard. I am allowing my subnet to uh, be inside that subnet group. I don't want it to be publicly accessible. I don't see a point in making a database publicly accessible. And as it is a kind of a EC2 instance and it has a network interface, it would require you to configure the security group around it. So you could choose an existing security group, or you could create your own security group and allow very specific services inside it. It is purely up to you. You need to open database ports so your application can connect to databases. I am here using the default security group and I do not want any specific availability zone preference. So I could select any of them, but let's select 1A. This is coming from the subnet we have selected. See, I am in Northern Virginia. This may have has six availability zone, but in my subnet group I have added only two. So I would be limited to 1A and 1B for this specific database. I could have a different subnet group which contains all six availability zone subnet, and I could have deployed things there also. Right. RDS proxy is a topic of its own, so I'll talk about that later. And here is a certificate which will ensure the SSL communication when you are talking to this particular service. That what I could specify here. Some additional configuration in the connectivity port number. I would use default port. This is my MySQL port number on which I would be connecting to. You can change it if you want. Then once you sorted the connectivity, here you would talk about database authentication. Your database has local users. So how you are going to authenticate to that? So password based authentication, if you remember, we have selected a user here at the top, which is named admin, and we created an auto generated password for that. So that database user will be there. And if you want that my authentication for the database should come from IAM, so some of the RDS engines support this method. MySQL is one of them. So you can even have your IAM user given power to perform database level operation on this database instance. Right? Or I could use password and Kerberos authentication. It is up to you. Monitoring would be allowing me to see what is happening with my database. I could enable detailed monitoring, enhanced monitoring here. Be aware it may attract little more extra charges for you. And if you want to configure some additional setting, these are available here. Like maybe I want to also get a new database created here. So maybe let's call it DB01. So I would have a database instance ready, and on top of it, I would get a database also set up for me that will be referred as DB01. And within that database, if I want to modify some parameter or add some extra setting, that is configured through parameter group or through options group. So parameter group, choose parameter group to define the configuration setting that you want applied to this DB instance. And what are your options group? This can be applied for things like I want to perform Oracle server encryption, MySQL memcached support. So additional engine level settings, if there are, they can be configured through parameter groups and option groups. I can select backup option, enable automated backup, a good thing, but maybe I do not need now. I would do this backup on my own later. And see this enable encryption by default selected, and it would use the default key coming from a service called AWS KMS, key management service, and these are the details which is displayed for me here. Right. So this is my KMS key ID. I can have log export, audit log, error log, general log. Most of the time when you are maintaining databases on your own, then you would have database engine configured to capture these logs, and that's the same thing you could do here also. Right. Now, IAM role, so there would be a service linked role, so we can have that role associated here for this log collection. Here is a maintenance option. This setting says enable auto minor version upgrade. So if I selected my, let's say 8.0.1 as my existing version, and if MySQL 8.0.2 becomes available, I want it to be automatically upgraded. So that is my minor version upgrade which we have selected. All my dot versions are considered as my minor version, and I can have my RDS service take care of that. So let's say it was 8.0.1 and now we have 8.0.2 or maybe 8.1.1, then the minor upgrade can be happening automatically. But if it is, let's say, 9.0 coming up, that will be considered as a major update, so you have to schedule that update. It won't happen automatically for you, but minor update can be configured to happen automatically, as we see here. Now, minor update may require some maintenance window, means there may be some downtime. Again, it depends on what type of update it is and what engine you are running and what configuration you are running. But we would not apply patches randomly. We may select a maintenance window. So you could say, hey, my database is not very busy from a time frame like between 10 p.m. to for next 1 hour it is not very busy, so probably apply all the maintenance on this particular time frame. And enable delete protection, it is just like an extra setting. So somebody by mistake selects it and says delete, it won't delete it. It will ask you to come here and disable delete protection first and then only allow you to delete. So a little additional safeguard from any accidental deletion which may happen. And if I look here now, I have my estimate cost. Right. So RDS free tier is available for you 2 months, 12 months. 750 of RDS single AZ DB T2 micro, T3 micro, T4G micro instances, up to 20 GB of storage and 20 GB of automated backup. So I am still into the limit. I haven't gone beyond anything. And now I would say create a database. This process may take little time because behind the scene there are a lot of settings happening for you. A server is getting ready. On that, the database AMI is being pushed. It would be configured with the setting you specified. It would be placed into the subnet you specified. So after some time, you would get your database available here. Currently, the status shows to me it is creating. MySQL Community Edition 1A we selected. No information about CPU. Maintenance not happening. It is in a VPC, yes. Is it a multi-AZ? Answer is no right now. Right. So this is what my database is getting ready as of now. Again, other options we could have some backup of databases and we could restore them from S3 if the need be. So maybe you have taken backup of database on-prem, you bought it to S3 by mechanism of copying or using some snowball devices, and afterward you could restore it as a RDS database if you want to. Right, so that is possible. Now, I would be stopping here and I'll speak to you into the next section. By that time, my database would be ready. We would have it into a running state. So I'll speak to you in next section. Thank you. So by the power of pause and resume, my database is now ready. We could see here that database is showing as available. At the top, there is a green bar which says successfully created database called database1. We have generated your master password during the setup because we asked them to do it, and that will be displayed in the connection detail. This is the only time you will be able to view the password. However, you can modify your database to create a new password at any time. So this is a one-time generated password. If you forget that, then you have to come back to this console and then create it. I could check the connection details here. What are my connection details? So don't worry, I would be deleting it before this video get released. That's why I'm revealing my password here. So this is my admin user, a master password which is generated for me. I could copy it and keep it somewhere so that I could reuse it if the need be. And then I have an endpoint. Endpoint is the location to which I would be making the connection request to talk to the database instance. So this is the location where my database service is running. This endpoint is currently into a private network. So what would happen? Let me draw that to you. So I'm just keeping one AZ here into picture, but you get the whole idea. And here is a subnet like this. So my database is currently hosted here into a private subnet. If I want to connect to it, it can happen from within this VPC only, nothing beyond it. So whatever I have here in this VPC, and if the routing table entry exists, they can communicate to my database. Shouldn't be a problem whether they are on AZA or in AZB. If I'm using default route table, they should be able to communicate to my database. And that is a good design because I would be hosting probably a web server here. This web would be exposed to public, and only this web server would be making context to this database for reading data. And that's how we are creating our architecture. Right. So that's why we have this private connection which we would be talking to within the VPC, not beyond it, because we have not exposed it anywhere else. So that is my endpoint. So this is a door on which you would be knocking to get into the database server. It will ask you username and password. Once you verify, you would get connected, and afterward you could perform operations there like creating a database, go into that database, create a table within that database, perform backup. Those type of stuff should not be a problem. So that is my connection string. It's not only visible here, but if you select this database here and you go into the details of it, you should be able to see this. So see this additional options available for me here. I could go in that, or I could just click on that, and now I would see additional information on that. Same data which we have seen is available here. Endpoint information, what port I'm talking to, which one version of US East 1A I am running on, VPCs which I am connected to, security group which is associated, certificate, when it is created. All this information is displayed to me, and my current security group is allowing traffic only from this security group, and outbound it is allowing for everyone. So that is my setting. Replication, there is only one instance, right? If you see here, US East 1, there is no source, no state, no lag happening. We'll talk about that, and I have not configured any proxy setting. There is no connection on this database as of now. No one is connected to this database. This is just freshly created for me. Here are some performance information about my databases like CPU utilization, class of this instance, region, engine version, engine detail, and all. Right. These tabs are self-explanatory, that doesn't require a lot of setting and understanding. Monitoring, I would have metrics being collected by CloudWatch, and they will be all displayed here, like number of connections happening, utilization, free storage, memory, and all the stuff. So I could use that. Logs would be collected. So anything which is happening can be configured with logs. So see this, we on February 17th, DB instance was just created. This is a good place to come and see if there is some activity happening on your database, and these are my SQL error logs. Upgrade if happens, the logs would be there. So these all logs are there which is being collected for me. I do not have operating system level configuration or operating system level access here. What I mean by that, so this is your DB instance. At the back end, it is an EC2 instance, right? And on top of it, my database is running. So I can't say that, hey, I want to SSH to this machine, or if it is a Windows based server, I want to RDP. No, you do not get operating system level access. This is a managed service. What you could do, you could launch your SQL tools, and those SQL tool or your program can be given access to this database, and then they can perform operation. But you do not have visibility of things running beneath it. You do not get access to the database instances directly. That is not required because AWS would be managing it for you, right? So hope this thing is clear. Then configuration. If you want to modify something, like maybe you want to change some of the engine version, maybe you want to change some setting of options group, password setting, storage setting. So these are all available. And if there is something recommended, that will also be there, like automated backup. We are recommending enable it. Enhanced monitoring is off. They are recommending you that, hey, enable this. That would be a much better way for you to see this database. Right? Any maintenance activity, if there are happening, we already selected auto miner. Pending maintenance. So if you do something on database, it doesn't directly apply that very moment the changes. It gives you option which says, do you want to apply this change in a maintenance window, or do you want to apply it immediately? So if there are a maintenance pending, this will be here. So this is a good place to come and check if somebody has already scheduled some maintenance task within your team, and are you also trying to step on his or her foot. So better to check here before you perform some additional maintenance operation which may be conflicting or which you may not want to perform in that time frame, just not to overlap with the maintenance window. Backup is currently disabled. I am not taking any backup. I have not taken any snapshot, but I can take snapshot if the need be. So if I say go ahead and take a snapshot, give it a name, and my snapshot would be captured, snapshot would stay independent. Even if I delete my database instance, I could still use that snapshot and recreate a database instance if the need be. That is all possible. And snapshot can be copied to cross region also. We have snapshot. If I take snapshot now, it would be local to Northern Virginia where I am currently, but that snapshot once ready could be replicated to other region if you want to maintain a disaster recovery environment in other regions. So that is all the simple, easy to understand, self-explanatory settings which are available there. Right. Now, let's talk about some more technical stuff, and then I'll come back to this to perform some modifications on that. So we will talk about high availability and read replica in a minute. We already understood what are the database engine. I talked about snapshot can be copied across region, right? You can use services, you can migrate databases using database migration service. So this is an independent service made available by AWS just in case if you feel, that you want to move your databases from on-prem or from other cloud provider, or you were running it on Amazon EC2 and now I want to bring it to Amazon RDS. That can all be done or accomplished by database migration service. In terms of pricing, you are paying for instance which is running here, right? So pricing would be based on what? Pricing will be based on demand, right? Let me come back here. On demand pricing, if I launch this instance for 1 hour or 2 hour, it would be, I would be paying only for that. That is my on demand. Or if I feel that I would be using this instance for regular purpose, I would go for reservation in that case too. Same like I can have a EC2 instance reservation. I can also have Amazon RDS reservation for long running and predictable workload. Right? So I hope this thing is clear to you. Let's now focus on RDS multi-AZ feature and read replica, and let's see what is happening. Now, to make things easy to understand, I am not creating multiple subnet here and create public, private and all, but consider that these services which I am hosting is in a private subnet. So I have a region A, I have a VPC, I have two subnet, and what I have done, I have just hosted a Amazon RDS database. So the connection string which we saw into the connection details page, that connection string is basically pointing to this. So if somebody connects to that connection string, they would be redirected to this Amazon RDS which we have just selected. If you want, if it happens, let's say if availability zone 1 goes down, or if this your database goes down for whatever reason, your application won't be able to access data. So what you could do, you could enable a feature on this database which is called multi-AZ, multi-availability zone, and it is just a checkbox for you. Once you enable this multi-AZ checkbox, what will happen? Amazon RDS service would be selecting another availability zone, another subnet depending on the subnet group you have created, and would be creating a standby instance there. So this is a standby instance. As the name says, it is standby. It is waiting to take over in case primary goes down, but it is not by default doing anything at all. It is not serving any connection. It is not improving the performance, but it is of the same size. So if this was a T2.micro, it will be T2.micro, right? So technically you will be paying for two instances, but connection will only be addressed by one. So my endpoint is currently pointing to my primary instance, and it will be doing a replication from primary to standby. There is a synchronous replication happening. Synchronous means that same time, if I write A here, same time it would be written here. I write B, it will be automatically returned into the different location. In AWS, ensure that this database remained into synchronization. So there would be no data loss if one of the availability zone goes down, because the write is acknowledged only when both of these have a valid copy of the data. So replication happening between these two, primary and a standby, is a synchronous replication. Keep that in mind. In exam you may get some questions around it. Now, database endpoint is pointing to this database here, and it would be having a entry for standby too. So I'm using a dotted line to represent it. Currently, it is not responding or accessing this standby database, but it knows about that standby. So in case your primary goes down, it will detect there are health check configured by the system for detection of health of the database. So if this health deteriorates, then this dotted line will become your solid line and your request would be forwarded to standby and your response will be given to you. This happens in very short duration, but yes, there may be little delay, few seconds when this switch over happens. So your application may have a small hiccup, but once my standby becomes the primary, then I would have no problem at all. And if if in my subnet group I have added a subnet from another AZ, then as soon as this primary is down, this standby becomes primary. It would again create one more standby for mitigating any further failures, right? So it will automatically find out if there is a subnet available and it is reachable as of now. It would then start creating a standby here, and that would ensure that if this again fails, you will have this standby taking over. So that is done by system itself. What we have here is called my multi-AZ configuration. So let me go to console and enable multi-AZ on the database which we have just created. I have to modify this database. So I will go into modification of this DB instance we have created, and then I would select a setting associated with its multi-AZ deployment. Right. Okay. So here is my detail of a database, password information, instance configuration, and this and that. I have this option here which says create a standby instance recommended for production. Default is do not, because I have selected the free tier, but now I am going beyond free tier. So if you are following along in your own personal account or any account when which you are worried about the payment, do not go for it. Otherwise there will be charges. So I'm creating a standby instance recommended for production. Let's see what happens. Creates a standby in a different availability zone to provide redundancy, eliminates IO freeze, and minimizes latency spike during system backup. What we mean by that? This is an exam question. The backup when will be performed, they would be leveraging the standby instance, not the primary. So if question comes in exam which says that your primary instance whenever a backup happens goes into a freeze and there are performance impact, what you could do, you could enable it to a multi-AZ, and if the backup detects that there is a multi-AZ configured, it would target the standby instance for performing the backup, not the primary instance. So that is a good approach if you have any spikes or you want to minimize the latencies and uh, still serve your customer during the backup. So create a standby. Right. So that's the only radio button I had to select, done, and I would go ahead and say okay, I am happy with this and let me continue. Now when I continue, so it will tell me that what I am changing. So I did not had any multi-AZ deployment and now I have selected the new value, and here is my option when I want to perform this maintenance. So you could say apply during next scheduled maintenance and it will be on February 28th at this time frame which I have selected. Or if you feel no, this is something which I can live with this right now, I'm okay to apply, go ahead and apply immediately and then your process would get started. So I'm applying this is right now without waiting for the time, and I say modify DB instance. Right. So simple setting, and we are into the modification process as of now. We just enabled it to be going through a modification. While this is happening, you could monitor the details on your log and event section. Right. We saw this before. So what we had, we had these things happening, and in some time I would start seeing more entry being added to this log, because now my database would go with the maintenance which we have just selected on it. So that would be happening in some time with it. Okay, so I'll come back to the screen and then I'll show you more details once this multi-AZ configuration finishes properly. We would come to that. So successfully modified, but the process is still going on behind the scene. So we'll see that in some time. Now my status has changed to modifying here. If you see, this is into modifying state. And if I come back here, I should have some more entry happening on it. So this modification converted to multi-ZB, DB instance created, and then DB instance restarted. So this process is going on. It may take little time, and once it is ready, I'll show you that how it looks from the console. Just give it a few minutes and we would be again resuming it. Right, so after a little while, my database status is available. Let's see if we have some event created here. So you can see this event happened. It applied the modification and DB instance created, DB instance restarted. Now everything is available and we are ready to see this database now. Did it change any connection string? Answer is no. The connection string, or sorry, endpoint details still remains the same. So this is still the same endpoint we are talking, but behind the scene there is one more database which is running here, right? So that's what happened when we created a multi-AZ configuration for our databases. And if something goes wrong, you would be able to see this information here. So let's say there is nothing right now wrong with this instance, it is running fine. And just to see this thing into action, let me go ahead and say I want to reboot this one. Right. So I do not see this thing like what is my second DB instance here. It is running into multi-AZ. I just initiated that, so it is there. But now I would be trying to go ahead and create a connectivity issue. Sorry, I would reboot this instance and we'll see that how it actually performs after this particular configuration. Let me quickly verify that it is a multi-AZ database. You could quickly check here by going here and it says yes, it is a multi-AZ database and it is running in the second AZ. Now I would go ahead and say let me reboot this instance and then we will see what happens behind the scenes. So see this DB instance reboot with failover, which means it would fail over to standby and then it would reboot the primary and standby will become the primary. That's what we are doing. So yes, let's reboot with the failover here. Done. And that process has been started on it. You could obviously verify that information again into your logs and event, and we will see what happens behind the scene when this database goes through restarting process. So I'll pause the video and I'll come back and we will see what happens afterwards. So now my database is showing as available. Let's see the entries here. Now, if you do not see all the entries, I would suggest to click on this gear icon and select how many the resources you want to see. 10 is sufficient for me to see right now. So I'll click on that and you could see information. So first modification we did started at 2133, finished at 2142, and then 2148, February 17th, I did a multi-AZ instance failover. That DB instance got restarted, multi-AZ instance failover completed, and this has been completed so far. So that information is being displayed, and if there were logs created, that will all be displayed, but my connection string still remain the same, and I am still serving my database. Shouldn't be a problem at all. So hopefully this thing is clear to you that how we are creating a multi-AZ database. Now, there is one more type of configuration we can have for these databases, which is called read replica. Let me go to slides and then I'll come back here and show you that. So what I could also do, yes, this is a good failover solution, but this standby is not working at all for serving any traffic. So what I could do, I could set up something called a read replica, or in short, we just call it RR. The idea here is if I have some use case where I am having lot of read type of query or lot of read traffic coming to my application, right? That read traffic could be maybe I have a dashboard application, maybe I have a reporting tool which is running, or maybe I am just doing some analysis and for that I have to uh, to do a lot of reading on that. So for that, I could create a read replica, and this read replica would be getting a new connection string, sorry, new endpoint, and then you can point your read traffic to these locations. But people get confused that if I have read replica, it will automatically receive traffic. Answer is no. So if you have one program here, this is your application. Now in this application, you could write code in such a manner that anytime if it is a read write request coming in, or let's say just the write request comes in, you could go ahead and say talk to the primary, right? That we can configure. And anytime a read request comes in, you could say talk to read replica. So you would need now two entries in your application. Whenever write logic kicks in, it will go to primary. Whenever a read request has to happen, you could point it to your read replica. So you could set up a read replica for your databases. And second thing, when you select a read replica, you could select a different size also. In primary and standby, whatever size we had here, the same size was here in terms of CPU, memory, and other setting. But a read replica can be configured with a lower or similar or higher configuration, shouldn't be a problem. And another point, read replica can exist within the same region like I'm showing you here. It can happen in any of the availability zone wherever you want to place, and it can be placed in a different region altogether, in a different VPC altogether. So this is also possible, and when these read replicas are accessed, that is happening over AWS global network. So we will go ahead and first set read replica, and I'll come back and talk about the type of replication which happens here. So I'm here on my database which is available. I want to modify that, and the modification, I want to set up a read replica for my databases. Okay. So for a read replica to function, one thing which has to be enabled is the backup. I just did that modification from the backend. Otherwise, my read replica option would not be displayed. So if you want to ensure that there is a read replica available for your workload, please go ahead and modify. If the backup is not there, enable the backup. And once the backup is enabled, you should be able to create read replica, right? So now I have option here which says I want to have a read replica created. So I'm now going ahead and saying create a read replica. So in this read replica section, I can select multiple settings. So you are creating a replica DB instance from a source DB. The new DB instance will have a source DB instance, DB security group, and parameter groups. So these two settings would be as it is into my replica also. I have to select a source. This is my source. DB instance identifier. This is unique key identifying the instance. So you could put information here, right? So that will be my, let's say, read replica 1 database 1, right? Not a very creative name, but it will work. As I said, I could have a different configuration for my read replica as we see here. So I could go ahead and use it's the same one, dbt3 micro, or I could have selected a different class for it. Plus, I could have hosted into a different region altogether. So sometime if your production system are in region 1 and your reporting services or dashboard runs into region 2, so that time read replica can be a really nice choice to go with. You can select it. And if you feel your read traffic would be too much, then you can make it bigger than your existing instances, or smaller depending on the type of traffic or number of queries coming to it. I would select different settings here. I could specify storage auto scaling, availability, and durability. So that will be already there. So we would have to not create a standby instance because it's a read replica. It won't have another standby. And now once I'm happy with all these settings, I should go ahead and just say I want to create a read replica. So what happens now? That the data, as you could see here from this primary, a read replica is getting created. There will be some time required for it. So I'll pause the video and I'll come back and we'll see how read replica actually works. While this is happening, let's go ahead and talk about one more thing. When you are creating a read replica, this is how your architecture is looking. The replication between primary and read replica is a asynchronous replication. What I mean by that? That there would be little bit of delay when your data is copied here. Maybe after plus few seconds, it would be available here. After plus few seconds, then it would be available here. So there will be always a asynchronous replication happening from primary to standby. Read replica will always be falling little bit behind, and that is referred as lag. So read replica would be lagging from primary database instance. It won't have real-time data, whereas in case of multi-AZ, this was a real-time data which is available in standby 2, but here it would be available after a few while. So in case an exam question says I need to have real-time data required for required for some workload, then read replica won't be a choice available for you. It won't serve the purpose best for that particular requirement. Now, once you have this read replica, and as you could see, I can have multiple read replicas also, no problem at all on that. Like I have created one, similarly I could go ahead and create another one also, shouldn't be an issue. And then all my read replica will get their own endpoint information. So read replica 1 will have its own endpoint, read replica 2 which I am sending will have its own endpoint, and I can then redirect my traffic to any of the endpoint depending on my use case. Maybe region 1, region B here, all the instances running in region B would be talking to read replica 2, and any instances running into region A, they need access to read data, they will be talking to maybe my read replica 1 here. So these are different endpoints available as you see here. Now, read replica obviously will serve read traffic, and in some cases, if you have a regional outage, you could promote a read replica. So the word we use is called promote. So promotion of a read replica would ensure that this becomes a read write copy. But be aware about one thing here. Two things. First thing, read replica promotion is not automated. You can automate it by using lambda function and event bridge functionality, but it is not out of the box available. You have to create that setting for you. So that is one. Second, when you are promoting a read replica and it is becoming a read write copy for you, its connection string would remain the same. So if your application here was taking or talking to DB endpoint, let's say it was called EP01 as an endpoint, application code is still referring to it. This read replica, when it is promoted, let's say it is my EP02 endpoint. So I may have to modify my application, then only it would be trying to talk to the read replica. So that is one way, that first we have to promote, and second, we may have to point my application to this read replica. Another way of doing the same approach could be that, let's say I have a DNS setting, and in DNS record, my database is currently pointing to endpoint 1 here. So my application code is not directly talking to this endpoint, but it is referencing the DNS name which we have, the DNS record which is present into my DNS server or Route 53. So what I could do, once I promote this read replica, I would get another endpoint. Let me call it endpoint 2, which I am getting. So I won't modify anything on my application, but I'll come to my DNS entry, and here it will say DB, you will be now redirecting request to EP2. So application level modification is not required. It still keeps on asking question on the connection on the endpoint called DB, and behind the scene it will start pointing to EP2 now. So that's how we would be promoting a read replica. So you promote it first, and then you either swap records into DNS or you modify application so the calls would come to the right location. All right. So hopefully this thing is clear. So read replica is a good solution. First thing, it can be created within account, it can be created across account, it can be of different sizes as well, no problem at all, but it is not real time. The replication would always be asynchronous, and you can have multiple read replica if you want, right? So hopefully by this time some process has happened in our environment. As we could see, this is still happening, modifying, it is available, but my read replica is still getting created. So let's give it few seconds. Once it is ready, I'll come back and we'll see some more details around it. All right. So now this read replica is ready. As we could see here, there is the primary, there is a read replica on top of it. And let's go ahead and see some of the details associated with it. Right. So now we have a different endpoint altogether, which is called RR1, database 1 and something else, whereas my traditional database endpoint was different. If I go to database 1, its endpoint is database 1, right? So there is a difference between endpoint. Plus, if I go back to my read replica, I should be able to see the events associated if there is any, like here, DB instance restarted, restored from snapshot, replication for the read replica resumed. So this all has happened when I initiated the process of getting this thing. Now, in its configuration, things can be changed if you want to. So this information is available. You could set up some setting, performance, insight information, instance size and all. That can all be set up, should not be a problem. And obviously, maintenance and backup can be enabled. Same thing like we could do into traditional way, that is also available if I want to perform some operations here. The one more interesting stuff which may be interested here is this. See this. So currently my replication status is into replication stage. It doesn't have right now any lag. So there, because there is no data, so there is no lag between both of them. And I could clearly see it is running in 1B and the read replica is running into 1A here and it is replicating. I could have had it into another region also, shouldn't be a problem. So I hope you have a better understanding of what is a read replica and how you could utilize it for some of your workload. So we will talk about more interesting stuff into the next chapter. Till then, enjoy your time. Talk to you soon. Thank you. Thank you for going through this training. I hope you found it useful and learned something new. Let me give you some additional resources to broaden your knowledge about cloud and learn more technical things. So these additional resources are listed here. The links are there into the description panel. You can click on those links and it will take you to those resources which I'm talking about. First resource I want to talk about here is a service summary cards book which I have authored and it is now available on Amazon. Sometimes AWS documentation can be so lengthy and so complex, and one thing can lead to another, and your focus can get diverted in a very easy fashion. So what I did here, I have created a single service page, a single page talking about all the important aspect about a service. What is the service, why I use it, when to use it, where the service would be running, who would be maintaining that service, how the service functions, how much I would end up paying for this particular service, and all of this information in a concise and a very uh, easy to read format in just one single page. So one page, one service. That's how I used this book, how I created this book. This book is available for all 12 certifications as of now, and I plan to keep it updated as the new release or new certifications are coming up. So check this book. You can find this book on Amazon in a Kindle and paperback format. And if you are using Amazon's Kindle Unlimited subscription, you would be able to get this book for free. So it's a nice read and it is targeted towards individual certifications, and you should be able to get a lot of information on one single page. Whether you are preparing for interview or an exam or just want to know about the service, this is a good handy reference for you. Second resource here is a architectural diagram quiz. So we know about individual services. How I can understand that how these services would fit together into a whole architecture. So what I did here, I have created a free online quiz. This is a web-based activity. So you would just go to a portal, don't need to log in, no need to buy anything. It's a free. So you could go ahead there and then see some instructions which will be displayed here in this panel. And then you would be dragging and dropping services based on reading this information. So you would read instruction and will say, okay, which service will be coming into first, what will be the second. And once you are done, you would submit it and it will tell you whether you did it right or not, and it will also give you the detail about the actual reference architectures where you can get more details on that. So it will help you to understand not only the service, but how it actually fits in the overall enterprise architecture. So check this activity also. Another resource you can find on Udemy are the free and paid trainings. So I'm trying to cover lots of AWS services and trying to make your certification journey easy. But I always consider that certifications are byproduct of learning. Your focus should be on learning things and not just passing certification. Yes, certification gives you an edge. It gives you a advantage over others who are not certified, but it is of no value if you do not know the technology at all. So in this training, I'm focusing on certification, but I'm not just saying that this is the important thing for a question. I'm also focusing on important aspect of those services and architecture. So you would probably get a lot of information once you go through this training. I prepare these training slides on my free time. It has been enrolled by thousands of learners so far. I have 4.8 plus rating for this training so far, and I'm trying to create both type of content, free and paid training also. All the core services, my plan is to make them free so that everyone can learn about core services. And when you want to pursue and learn about specific track like security or architecting or system operations or development, maybe those will be a specific track training which you would be getting there also on the digital format in Udemy. So I'm preparing these training and making them available as they get ready. Next program is something which is very near and dear to my heart, that is called Become a Solution Architect. Some of our solution architects have worked together. They are all AWS employee working with enterprise customers, helping lots of customers on day-to-day basis. We saw that this was a large, huge gap between people who we interview for different roles in AWS. Sometimes they may not have good technical knowledge, or sometimes they lack some behavioral skills required to become a solution architect. So we wanted to bridge that gap, and that's why we started this program called Become a Solution Architect, a free program. We run it online. We deliver technical sessions and behavioral sessions every Saturday on Twitch, and then we record and post it onto YouTube, and we run different tracks on that. So far we have run a serverless track, we have run a networking track, and we plan to run more tracks on analytics, machine learning, and maybe databases, so that people would not just learn a specific technology, but they would also understand a specialist track and then can deepen their skill if they want to learn more about that specific track. So check this program. It is voluntary, run by some of my awesome colleagues at AWS and me, and we help a lot of people so far. We were able to help a lot of people so far, and interview preparation tips, how to answer question into star format, which is very unique way of Amazonian interviews. So we talk about lots of stuff there. So check this program. We run these batches every quarter. So probably depending on where you are watching this training, there may be a batch available or maybe soon to be launched. So get in touch and we would be happy to help you in getting enrolled in this program. This link is available here, so you could click on that and get more detail about the BESA program page. Last resource I have here is the book which I'm working on with some of my colleagues in AWS, which is called Cloud Computing Concept and Tech Analogies. What we tried here, we tried to create a novel, a fiction, a book, like a story, but in that story, you are dealing with characters, or characters are dealing with situation like a group of new hires who want to migrate their infrastructure to cloud. They joined a company's traditional company who is running everything on-prem. People are skeptical about cloud. Then how that group of people go through understanding cloud, exploring different options available, help migrate their workload to cloud, and then benefit from those things which cloud offers. So that is the journey you would follow here with different characters within the book. And I'm pretty sure once you go through this book, you would be able to relate some of the characters we have used in the book in your real life, in your office, your colleague. They may sound familiar to what we have used into this book. So we are trying to relate your knowledge from classical IT on premises to new cloud concept, and this is scheduled to be released in May 2023. I'm not sure when you are watching this training, so probably it would be released or maybe about to release or already been released till you watch this. So this is all additional resources to help you learn further. I hope you enjoyed, and I'm all ears for feedback. Anything good and bad, any criticism, anything which I can do to improve the learning, any additional feedback you have, feel free to reach out. Anything which can help make these trainings better, I am all ears for it, and I want to get connected with like-minded people. This is my LinkedIn. I may not respond to every message that very moment, but I take additional time, or I make sure that I respond to as many messages as I can. So just get in touch. If your feedback, or even if you do not have a feedback and just want to get connected, why not? Let's get connected. So all the best, enjoy the learning, and keep up the good work and keep on learning new stuff. Thank you.